Long before science learned to ask the right questions, platinum had already chosen silence. It existed without explanation, without apology, without context. Humanity walked past it for generations, unaware that it was touching something older than memory itself. While civilizations rose and fell, this metal remained unchanged, untouched by air, untouched by water, untouched by time. In the quiet corners of the natural world, platinum waited. It waited in river sands, hidden beneath flowing water. It waited in rocks that never spoke of their origin. It waited while humans learned to shape stone, then bronze, then iron. Each new age believed it had mastered matter, yet this single element stood apart, unmoved by progress. Platinum was not rare because it was weak. It was rare because it did not belong. Every element around it told a familiar story. Iron spoke of blood and war. Copper spoke of tools and trade. Gold spoke of power and greed. Platinum spoke of nothing at all. Its silence was complete. And silence, when stretched across centuries, becomes unsettling. Early metallurgists felt it. They sensed that something was wrong. Their fires could bend iron, but not this. Their acids could scar silver, but not this. Their hammers could shape gold, but not this. Platinum did not resist aggressively. It simply refused to participate. That refusal planted discomfort in the human mind. Civilizations prefer materials that obey, materials that submit. Platinum did neither. It existed on its own terms, governed by laws no one yet understood. To ancient hands, it felt alien, as if it had fallen into the world by mistake. In truth, it had. The Earth is a selective place. During its violent birth, the planet sorted matter with brutal efficiency. Heavy elements sank toward the core. Lighter ones remained above. This process was not gentle or random. It was final. Anything as dense as platinum should have disappeared into the depths forever. But platinum remained near the surface. That alone was a contradiction. If Earth could not hold it, then Earth could not have made it. And if Earth did not make it, then its presence was a message. A quiet one. A message written in atoms rather than words. Platinum's atoms were unusually stable. Their structure resisted decay. Their electrons held tight. Their bonds did not break easily. This was not the behavior of matter formed under ordinary conditions. This was matter shaped by extremes, refined by forces far greater than volcanic heat or planetary pressure. Still, humans did not yet know where to look. For most of history, the sky was decoration. Stars were lights, not laboratories. They inspired myths, not measurements. The idea that the heavens could manufacture matter had not yet taken form. The universe was distant, detached, unrelated to the dirt beneath human feet. Platinum quietly contradicted that belief. Its density hinted at violence. Its rarity hinted at limitation. Its endurance hinted at age. Everything about it suggested a past that Earth could not provide. The element carried the weight of something unfinished, something unresolved. Time passed. Empires collapsed. Knowledge accumulated slowly. Fire became science. Curiosity became method. Humanity began to understand atoms, then nuclei, then forces invisible to the eye. Only then did platinum begin to feel less mysterious and more impossible. Calculations revealed a harsh truth. The energy required to create such an element exceeded anything Earth could generate. Even stars like the sun fell short. Platinum required environments where matter was compressed beyond imagination, where particles collided faster than decay, where moments were violent enough to rewrite atomic structure itself. Such places were not common. They were rare, catastrophically rare. And suddenly, the silence of platinum made sense. It was not hiding. It was remembering. Every atom carried a history of pressure and chaos, of creation through destruction. Platinum was not a child of Earth. It was a refugee, a survivor, a remnant of events so powerful they reshaped space itself. Yet it had arrived quietly. No explosion marked its landing. No record captured its fall. It blended into the planet as if it had always been there, patiently waiting for minds capable of asking the right questions. The unknown was no longer ignorance. It was anticipation. Humanity stood on the edge of a realization it was not yet ready to face. That the planet was not isolated. That its materials were not local. That its story was part of a much larger narrative written across galaxies and time. Platinum was the first whisper of that truth. A whisper that said the universe does not only surround us, it lives within us, in our tools, in our technology, in the elements we hold in our hands without understanding their origin. The unknown was not empty anymore. It was watching, waiting for the moment when humanity would finally look beyond Earth and realize that some answers are not buried beneath the ground, but scattered among the stars. Human history moves forward through experiments. Not all experiments are planned. Some begin as accidents. Others begin as mistakes. Platinum entered human knowledge through both. It was not discovered because people were searching for it. It was discovered because it refused to disappear. In the early 16th century, Spanish explorers arrived in South America with one purpose: gold. Rivers were sifted. Sand was washed. Shining flakes were collected with obsession. But among the gold, something heavier appeared. A dull white metal that ruined the process. It clogged tools. It resisted heat. It contaminated purity. Miners cursed it and threw it away. They named it platina, a word filled with annoyance rather than respect. No one tried to understand it. No one tried to refine it. The experiment ended before it began. 2 centuries later, curiosity returned. In 1735, a Spanish naval officer and scientist named Antonio de Ulloa joined a scientific expedition to the region of modern Colombia. Unlike miners, Ulloa was trained to observe. He noticed the strange metal behaved differently from silver and gold. It did not corrode. It did not melt. It did not react. Ulloa collected samples and carried them back to Europe. In 1748, he published the first scientific description of platinum. For the first time, the metal entered laboratories instead of riverbeds. The experiment had officially begun. European scientists were intrigued. Platinum challenged everything they understood about metals. In England, William Brownrigg studied its chemical resistance. In Sweden, Henrik Schäfer tested its behavior under extreme heat. Across Europe, the same conclusion emerged. This was not an ordinary substance. The greatest obstacle was temperature. Platinum refused to melt in conventional furnaces. Gold surrendered easily. Iron eventually softened. Platinum remained solid. This forced scientists to invent new methods. They dissolved it chemically. They compressed it as powder. They experimented with purification techniques never used before. Platinum was shaping science as much as science was shaping platinum. In 1783, French chemist François Chaboneau succeeded in producing workable platinum by removing impurities and carefully controlling heat. It was a breakthrough. Platinum could finally be shaped into tools and instruments. But shaping it did not explain it. Another problem emerged: scarcity. Platinum was extremely rare. It appeared in thin sediments and isolated deposits. It did not form large veins like iron or copper. This raised a disturbing question. If platinum formed inside Earth, where was the rest of it? Geologists began comparing platinum locations. They noticed a pattern. Platinum was often found near materials associated with meteorites. This observation was subtle at first, but impossible to ignore. The experiment expanded beyond chemistry. By the 19th century, atomic theory transformed science. Matter was no longer continuous. It was structured. Nuclei held protons and neutrons. Energy held them together. Suddenly, scientists could calculate what it took to build an atom like platinum. The numbers were alarming. The energy required exceeded anything Earth could produce naturally. Volcanoes were insufficient. Pressure inside the planet was insufficient. Even the sun could not provide the conditions. Platinum did not fit planetary physics. This realization forced science to look outward. Astronomy became the new laboratory. Telescopes replaced furnaces. Equations replaced crucibles. Scientists studied how elements formed in stars. They learned that stars fuse lighter elements into heavier ones, but only up to iron. Beyond that point, fusion fails. Platinum lay far beyond iron. The experiment reached its limit. If Earth could not make platinum and ordinary stars could not make platinum, then something else had to. Something violent. Something rare. Something extreme. In the 20th century, physicists began simulating stellar explosions. Supernovae released enormous energy. They scattered matter across space. These explosions could create some heavy elements, but calculations showed they still fell short. The experiment demanded a new hypothesis. Attention turned to neutron stars. These objects were discovered through theory before observation. They were remnants of massive stars, compressed beyond imagination. Scientists proposed that when two neutron stars collide, conditions emerge that exist nowhere else in the universe. The idea was radical, but the equations worked. Under extreme neutron density, atomic nuclei could rapidly grow heavier. Platinum appeared naturally in these simulations. For the first time, science had a process that made sense. Still, it remained unproven. The experiment paused at the edge of certainty. Humanity had built the theory. The universe now had to confirm it. The stage was set. Science waited. For a long time, platinum remained unanswered. Science had measured its weight, tested its strength, and documented its resistance. Yet the question of origin refused to settle. Every experiment pointed away from Earth. Every calculation suggested a birthplace far beyond familiar skies. The mystery was no longer chemical. It was cosmic. The revelation began with a limit. Astronomers learned that stars, despite their power, are restricted. Inside their cores, fusion builds elements step by step. Hydrogen becomes helium. Helium becomes carbon. Carbon grows heavier with time. But the process ends at iron. Iron is a wall. Beyond it, fusion drains energy instead of creating it. A star cannot cross that boundary and survive. Platinum exists far beyond iron. This single fact changed everything. If normal stars could not create platinum, then its origin demanded a different environment. One defined not by balance, but by collapse. Not by stability, but by violence. Scientists realized they were searching for moments when nature itself breaks its own rules. In the mid-20th century, astrophysics offered a dangerous idea. Heavy elements could form during catastrophic events where matter is overwhelmed by neutrons. In such conditions, atomic nuclei absorb particles faster than they can decay. They grow heavier in seconds. This process explained elements once thought impossible. The theory was elegant, but theory alone is fragile. For decades, scientists looked toward exploding stars for confirmation. Supernovae are among the most powerful events in the universe. They scatter matter across galaxies. They reshape space around them. They seemed like perfect factories for heavy elements. Yet detailed simulations revealed a problem. Supernovae could not account for the abundance patterns observed. Platinum remained unexplained. Once again, science faced a contradiction. Then attention shifted toward objects that defied intuition. Neutron stars. Neutron stars are not stars in the traditional sense. They are remnants. The crushed cores of massive suns that collapsed under their own gravity. Their density is extreme beyond language. Matter inside them is compressed so tightly that atoms dissolve. What remains is a sea of neutrons bound by gravity itself. These objects orbit silently, invisible until disturbed. Scientists began to ask what would happen if two neutron stars met. The answer was terrifying. As neutron stars orbit each other, they lose energy through gravitational radiation. Slowly at first, then faster. Space itself begins to ripple. Time stretches. The stars spiral inward until collision becomes inevitable. When they finally merge, the release of energy is unmatched. Matter is torn apart and thrown into space. Neutrons flood the environment. Atomic nuclei grow violently heavier. In this chaos, platinum forms naturally. For years, this idea lived only in equations. Then the universe confirmed it. On August 17th in the year 2017, detectors on Earth recorded a signal unlike any before. Instruments designed to sense distortions in space-time itself began to vibrate. Scientists traced the signal to a distant galaxy over 100 million light-years away. Two neutron stars had collided. The event was named GW 170817. For the first time, humanity did not merely observe the universe. It felt it. Seconds later, telescopes around the world turned toward the source. What they saw was extraordinary. A brilliant flash of light followed by a fading glow. This phenomenon became known as a kilonova. Its light carried information hidden within its colors. When scientists analyzed the spectrum, the revelation was complete. The signatures of heavy elements were present: gold, platinum, and others beyond iron. The data matched predictions exactly. The universe had provided direct proof. Platinum was being created before human eyes. The mystery that spanned centuries collapsed in a single moment. The element that confused miners, challenged chemists, and frustrated physicists finally revealed its birthplace. It was not forged gently. It was born in destruction. But the story did not end there. Once created, these heavy elements did not remain where they formed. They were ejected into space, carried by expanding clouds of debris. Over millions of years, this material mixed with cosmic dust. It became part of forming solar systems. When planets were young and unstable, meteorites delivered these elements to their surfaces. Earth received platinum during its earliest chaos. That is why it is rare. That is why it is scattered. That is why it rests near the surface instead of the core. It arrived after Earth had already formed. Suddenly, everything aligned. Platinum resisted corrosion because it was forged under forces that destroy weakness. It endured heat because it was born hotter than any furnace. It survived time because it was older than the planet itself. The revelation reshaped perspective. Platinum was no longer just an element. It was evidence that the universe and Earth are deeply connected, that matter travels across unimaginable distances, that our planet is built from fragments of distant catastrophes. Every piece of platinum carries the memory of colliding stars. And now, humanity finally understands why the element that should not exist is here at all. When platinum reached Earth, it did not announce its arrival. It did not crash loudly or mark itself with fire. It settled quietly into the planet, waiting for intelligence to catch up with its existence. For billions of years, it remained unused, unnoticed, and unappreciated. Then humanity arrived, and everything changed. At first, platinum meant nothing. Gold defined wealth. Iron defined strength. Silver defined trade. Platinum remained invisible to ambition. But consequences do not require attention to exist. They only require time. Once science learned how to shape platinum, its influence spread silently into every corner of civilization. Its resistance to corrosion made it valuable in environments where other metals failed. Its stability allowed it to endure heat, pressure, and chemical attack. These qualities were not accidental. They were inherited from its violent birth. In the 20th century, platinum entered medicine. Scientists discovered that certain platinum compounds could interrupt the division of cancer cells. Drugs like cisplatin changed the future of treatment. Lives that would have ended early were extended. Suffering was reduced. Hope increased. A metal born in stellar destruction became a tool for preservation. This was not poetry. It was consequence. In technology, platinum became essential. Electronics relied on its reliability. Sensors depended on its precision. Hard drives trusted its stability. As devices grew smaller and more complex, tolerance for failure disappeared. Platinum answered that demand. It did not degrade. It did not forget its structure. It performed consistently across time. In energy and environment, platinum shaped the air itself. Catalytic converters used platinum to reduce harmful emissions. Invisible reactions took place every second beneath vehicles, transforming toxic gases into less dangerous forms. Cities breathed easier because of an element most people never saw. Platinum did not seek recognition. It functioned silently. In space exploration, platinum returned to the environment that created it. Spacecraft required materials that could survive radiation, temperature extremes, and vacuum. Platinum endured where others failed. It became part of humanity's attempt to leave its home planet, carrying cosmic matter back into cosmic space. The consequence was circular. An element born in stellar violence now enabled humans to explore the universe that created it. Yet this power came with limitation. Platinum is rare. Its scarcity shaped economics and ethics. Mining it required effort, technology, and environmental sacrifice. Decisions had to be made. How much land could be disturbed? How much water could be used? How much damage was acceptable for progress? The element forced humanity to confront its priorities. Platinum could not be wasted. It had to be respected. In culture, platinum slowly gained meaning. It became a symbol of endurance, of permanence, of something that does not fade. It marked milestones and commitments, not because it was shiny, but because it lasted. Unlike gold, it did not boast. It endured. This endurance carried a lesson. Platinum reminded humanity that strength does not always announce itself, that the most powerful things are often quiet, that survival is sometimes more meaningful than dominance. The presence of platinum changed scientific thinking as well. It proved that Earth's composition is not purely local, that planets inherit material from distant events, that our world is a mosaic of cosmic history. This understanding reshaped planetary science. It influenced how scientists searched for life elsewhere. If Earth carried materials from beyond its origin, then other planets might too. The universe was no longer a collection of isolated systems. It was a shared environment. The consequence expanded beyond platinum itself. It altered how humanity viewed existence. Every use of platinum became a reminder that creation and destruction are linked. That life-saving medicine can come from stellar death. That beauty can emerge from catastrophe. That violence and hope are not opposites in the universe. This realization was uncomfortable. It challenged simple narratives. It challenged moral certainty. It challenged the idea that the universe is either kind or cruel. Platinum suggested that it is both. Human progress, built partly on this element, carried responsibility. To understand where materials come from. To respect their rarity. To acknowledge the processes that made them possible. Platinum demanded awareness. As technology advanced, dependence grew. Modern society could not easily replace platinum. No synthetic material matched its properties fully. Its absence would slow medicine, energy, and exploration. Its presence accelerated them. Humanity had unknowingly tied part of its future to a gift from colliding stars. That dependency was humbling. The consequence was not just practical. It was philosophical. Platinum forced humanity to accept that it is not separate from cosmic history. That daily life is influenced by events that occurred long before Earth existed. That every object carries a lineage. The metal in a laboratory instrument. The catalyst in a car. The component in a satellite. Each one traced back to a moment of cosmic violence. This connection dissolved distance. The universe was no longer distant. It was present. In using platinum, humanity interacted with the aftermath of stellar collapse. It benefited from ancient destruction. It turned catastrophe into capability. That is the consequence. An element that should not exist on Earth became essential to life on it. And in doing so, platinum quietly reshaped what it means to be human in a universe that creates through chaos. When the story of platinum is finally understood, something quiet happens inside the human mind. Not excitement, not triumph, but humility. Because this element does not celebrate discovery. It questions it. It forces humanity to pause and reconsider its place in a universe that creates through extremes. Platinum is not impressive because it is rare. It is impressive because it exists at all. It should not be here. Yet it is. That single contradiction carries meaning. For centuries, humans believed the Earth was the center of creation, that its materials were born beneath mountains and oceans, shaped solely by planetary forces. Platinum dissolves that illusion. It proves that our world is not closed. It is open, exposed, influenced by events far beyond its horizon. The ground beneath our feet is not purely earthly. It is cosmic memory. Platinum reminds us that time does not belong to humans. Its atoms were forged long before language, before thought, before identity. Civilizations rose and fell while it remained unchanged. Empires collapsed while it resisted decay. History passed while it waited. This endurance is not arrogance. It is patience. In that patience, there is a lesson. Human lives are brief. Human conflicts are brief. Human fears are brief. Yet we often act as if they are permanent. Platinum exists as quiet evidence that permanence belongs elsewhere. That endurance is earned through forces we barely comprehend. The universe does not hurry. It does not explain itself. It creates, destroys, and moves forward without asking permission. Platinum is a fragment of that process. Its journey from stellar collision to human hand is not meaningful because it ends with us. It is meaningful because it never needed to. Humanity is a chapter, not the conclusion. The element would exist whether or not we learned its name. This realization can feel unsettling. It removes comfort. It removes centrality. It removes the illusion that existence revolves around observation. But it also grants freedom. If we are not the center, then we are participants, witnesses, temporary carriers of ancient matter. That perspective changes how knowledge feels. Science becomes not conquest, but conversation. Not domination, but listening. Platinum was speaking long before we understood its language. The universe speaks in patterns, not words. In forces, not intentions. Platinum is one such pattern. A reminder that complexity emerges from chaos, that beauty can arise from destruction, and that stability can be born from violence. This does not make the universe kind. It makes it honest. The reflection extends inward. If the materials that sustain modern life come from distant catastrophes, then progress itself is inherited. We build our future using fragments of the past that we did not create. Responsibility follows naturally from that truth. To waste such material is not merely inefficient. It is disrespectful. Platinum carries a cost measured not in currency, but in cosmic rarity. Its creation required conditions so extreme that the universe produces them reluctantly. To treat it as ordinary is to misunderstand its value. This understanding invites restraint. It encourages balance. It suggests that advancement without awareness leads to fragility. That power without humility collapses under its own weight. Platinum survives because it was forged under pressure we cannot replicate. Humanity survives by adapting, learning, and remembering. Forgetting where things come from has always been dangerous. The element also challenges ideas of purpose. Platinum was not created to heal disease. It was not created to clean air or enable exploration. It had no intention, no design, no goal, and yet it became essential to all of these things. Meaning, then, is not assigned at creation. It emerges through use. This realization applies beyond elements. It applies to knowledge, to culture, to existence itself. Purpose is discovered, not predetermined. Platinum teaches this silently, through its presence rather than instruction. There is comfort in that. It suggests that meaning is flexible, that even products of destruction can become instruments of preservation, that endings can seed beginnings. In this way, platinum becomes more than matter. It becomes metaphor, a symbol of resilience without aggression, of endurance without dominance, of strength that does not demand attention. It does not shine loudly. It does not fade quietly. It remains. Perhaps that is why it resonates. In a universe defined by change, platinum represents continuity. In a species defined by urgency, it represents patience. In a civilization driven by consumption, it represents rarity. The reflection is not about the element alone. It is about us. We are made of materials forged in stars. Our bodies contain atoms older than Earth. Our existence is temporary, but our components are ancient. Platinum makes this visible, tangible, undeniable. When humans hold it, they are holding deep time. That realization can inspire wonder instead of fear, gratitude instead of entitlement, curiosity instead of control. The element that should not exist teaches that impossibility is often perspective, that absence of understanding is not absence of truth, that the universe does not owe us simplicity. Platinum existed before we asked questions. It will exist after we stop. And in the brief moment between those two realities, we are allowed to understand it. That is enough.